Hey guys, welcome back to my video. I'm JV's Call and I'm from SMJK Kuching. Recently I'm thinking about what to do for today's video. Do you have any suggestion? Scientific experiment. It's definitely a brilliant idea. It has been a long time since I did perform the experiment. So guys, I'm going to show you 4 experiments about cosmology and acquainting you the knowledge behind the experiment. Let's go! Why is these people always says that the earth is flat? Are they even listen to the teacher in school? Or they are just be a wormhole that listen in the left ear and out from the right ear? Flat Earth Society. The people who always says that the earth is flat. They are often motivated by the pseudoscience or religion literalism. They use different kinds of social media to spread their disinformation and spread their erroneous idea. Maybe I can set up an experiment to prove that they are actually wrong. So, for the first experiment, you will need a magnet, a paper, a cardboard, and of course, you will need 3 springs. All you have to do is place the magnets underneath the paper and press it for the shape. After that, put one of the spring at the center of the magnet. Cut the cardboard into pieces and apply some glue on the surface. And put it beside the spring, just like this. Now, here is the point of the experiment. Put the 2 springs behind the cupboard. As you can see, the spring's one end is tilted to the magnet because of the magnetic force. After watching the observation, what do you think? Assume that the magnet is the Earth's core and it has the gravitational force. The trees are springs and the flat Earth is this length of paper. It can really prove that the Earth is actually sphere. For the sphere Earth, the trees are growing upwards as the gravitational force pulls in the same direction as negative gravitropism. However, in this case, the trees are growing at an increasingly sharp angle as the gravity is located at the center. It's interesting. Guys, want to learn more about history again, but of course not in Malaysia like Dato' On Jafar and Tunku Abdul Rahman. It is about heliocentric theory. Have you ever heard that before? Heliocentric theory. It is about the sun is at the center of our solar system and the planets revolve around it. It is a general knowledge that everyone should know, right? But in the ancient times, nearly about 1000 years of the century, Aristotle's view of a stationary Earth at the center of revolving universe dominated the nature philosophy. Nobody dared to break this rule, because once someone was broken the rule, he will be burned alive in the public. It's terrible, right? This myth went about 500 years and more until a Polish priest named Nicholas Copernicus proposed that the Earth was a planet like Venus and Saturn circle around the Sun. However, afraid of criticism, he did not publish his theory until 1543, shortly before his death. After that, an Italian scientist named Gargano Bruno, not Bruno Mars, don't think too much, was burned at the stake of teaching Copernicus' heliocentric view. However, theory of heliocentric is successfully accepted with support of Isaac Newton, Galileo Galilei, and Johannes Kepler. They are the true heroes of our education system now. We need to do an experiment to commemorate them and give them a clap. We all know that we need to wait for 24 hours for sun to set and to rise, right? So today I'm going to use this concept to understand that the sun is at the center of our solar system. So let's go. So for the second experiment, we will need a ball, a compass, a torchlight, a marble, and of course a blank piece of paper. All you have to do is construct two circles in the center of the paper with the compass. Next, place the ball in the center of the first circle. After that, place the marble on the line of the first circle, just like this. Now, here's the point of the experiment. Turn on the torchlight and revolve the ball according to the second circle you have drawn. As you can see, the part of the ball is illuminated when the torchlight makes the circle. So guys, what did you think after you have watched the observation? Assume that the torchlight is the sun, the ball is the earth, the bubble is the moon, and the circle on the paper is the way that the planets travel around the earth. So, when the sun is going around the earth like this according to geocentric theory, the illuminated part means the day, while the back side of the earth means the night. Try to think, what if the people who live in this have the sunrise at this time? When the sun moves away from them, they need to take 365 days for another sunrise. If the distance between the Earth and the Sun is same to the heliocentric theory. But do we need to take this? Do we need to take so long time? No. We take 24 hours for the next sunrise. So there is only one possibility. The heliocentric is true, while the geocentric theory is false.
Oh, don't leave! Is our experiment performed way too easy? We still have 2 experiments to go. The next experiment is going to be learning about how gravity works. I would say that it is more than an apple falling onto your head and make you drizzling. So, I'm going to introduce you a new phrase, fabric of space and time. Now, let's imagine that space is a fabric and it is elastic. Suddenly, a mass falls on it. That is what exactly we are going to do today. Let's experiment. You will need a trampoline or something to be alternative. A short put, but of course not too heavy, and some marbles.
Do is put the short put on the basin and let it create a dent. Secondly, you need to place the marbles and let it spiral inwards the dent, just like this. As you can see, the mass creates a dent and the marble spirals inside the dent. Try to think, if there is no mass, is there any way to form a dent and let the marbles go in it? No. So, there must be a mass to create a gravitational force like Earth, Jupiter, or Venus. If a planet travels at constant high speed, it will not fall in the dent.
Icarus is located about 9 billion light years away from us and is too far for us to observe. Gravitational lensing is the bend of light by massive galaxy crystal in the line of sight. It helps to magnify the star 2,000 times to be discovered. Just like this shot, the light is bent by the galaxy crystal and when it reaches to the intersecting point, it will be magnified about 2,000 times for us to discover. Thanks to this rare cosmic alignment to allow us to discover this lonely star. Maybe it doesn't feel lonely anymore. Amazing, right? There is still a lot of mystery remains in the universe for us to explore. Let's proceed to our last experiment. Let's go!
Ever wonder what happened if 2 very high dense objects are collided to each other, just like the black holes? It releases tons of gamma ray, which more than the energy that given by our sun. So, for the last experiment, I'm going to perform the LIGO demonstration, which is frequently used by the NASA to detect the gravitational waves. When the very high dense objects are collided to each other, it creates a ripple on the fabric of space and time, and these ripples are often called as gravitational waves. In order to do this experiment successfully, you will need 2 lasers, 2 books, random books, and of course 2 mirrors. All you have to do is set up an experiment like this. Put the mirror at the center while 2 books away from it. Keep adjusting 2 of the mirrors until the laser can be reflected at a 90-degree angle or perpendicularly, just like this. Well, the other one is same too. The laser releases the interference pattern
and will get disturbed if a ripple is created. The books as the computer program screen will detect the disturbance and hence conclude that a ripple exists. But of course, this is not a real LIGO. The real LIGO has a laser beam that length about 4 kilometers across and have many computers to progress or to conclude that the ripple exists. Why is it do so? Because the gravitational waves passed to the Mother Earth can be weakened by the distance from the outer galaxy or outer solar system. So, they will need a bigger LIGO to conclude that the gravitational waves exist. The small one like this will not detect anything.
When two high-density objects like black holes are collided, ripple will created on the fabric of space and time. When the ripples are close enough to the Earth, the LIGO will detect the ripples and send the information to a computer for further interpretations, like when and where. Congratulations everyone! You have mastered Chapter 1 of Cosmology. Cosmology is very simple and is easy to learn, right? However, there is still a lot of mystery remains in the universe for us to explore. I hope you can learn something in my video and teach other people too. I'm Javisco and I'm from SMJK Kuching High. Let's join me to explore the remainings of mystery in the universe now. Let's go!